Okay, for heap time complexity, I start from heapify, which is means creating heap. So time complexity of this is O log n. So O notation log n. So let me, oops, sorry, make this because we have a lot to say. Let me, so, excuse me, okay. Okay, so for heapify, we said that for build heap, just time complexity gonna be on, just to build. And to get mean, so to get minimum in heap, time complexity gonna be O1, actually for mean heap. And of course for get max, for max heap gonna be the same. Gonna be the same for max heap. And that's why we make heap, or we use heap. To extract mean, time complexity gonna be O log n. And for decrease key, time complexity gonna be same, O log n. For inserts, time complexity gonna be O log n. And for delete, time complexity again gonna be O log n. About a space, so heap a space complexity is O1. And so of course all of this, for all of this, n is the number of capacity or nodes inside here. Okay, so after time complexity, we jump to creating our heap. So what I do, I just say public, because I want to make this available as a data structure. So I create public struct heap. I'm gonna make it generic, so from type T. So this gonna be my heap, and here I start from variable nodes, which is equal an array of type T Technically going to be empty at the beginning. Then I'm gonna create private variable by the name of order criteria T and T. That return Boolean. And yeah, if I want to just write some description for this, just say determines how to compare two nodes. Technically, yeah, compare these two. And for max and min gonna be different. We'll go over later. Okay, private variable. Again, I'm gonna create another private variable. I name this one actually yeah, let's do this later. So I'm gonna create a public init. So to the constructor for this, I just say sort, because I want to init it. I want to say, okay, which order you want to. So I just use escape ping T and T to be Boolean. And inside this, I'm gonna say, okay, self dot order. I just create here order criteria. Order criteria equal sort. So with this, we can create empty heap. Also, here we mentioned that the sort function determine whether this is main or yeah. So how we can find its you know, yeah, min or max. So for comparable data types makes max heap and smaller sign makes a min. Okay. So now we will go after you know, writing initial init, then we can write another public init and in this init we get one array from type of T. Also we get sort, again at escaping. Actually, this at escaping, I need to explain that this is a keyword. If we put it, in function signature, says that this closure can escape. So it means that can finish later. So so this gonna be use of this to finish this later. We use this usually a lot, actually, for example, for data source or something that's loading image, when something take time and make finish after our function, we use this. So again, for this one, the difference is that this one just gets sign a sort that say that this is man or max or min heap, but this one gets an array as an input as well. So configure heap from array, but we don't have this configure heap, we don't define it yet, but I'm gonna define this to create array from and actually create heap from one array. Other things that other private function that I make, also it is mutating function that configure heap, and just here I use that. So this one gets from array type of T, and inside I get nodes equal my array, and I say for excuse me, for I in stride with from nodes dot count divide by 2 minus 1, technically 1, and throw 0. So anyway, I start to 0 by steps minus 1. Usually we use CRID for when we want to create a range, from big to bigger, start to small. So this one I just say shift down. What? I. So slowly, one by one, I shift down each element to my heap. So another actually variable that I property that I need to create is var is empty. If you remember in realize, so by this one I can find if my heap is empty or not. So what we do, just return my nodes dot is empty. If my nodes, so my array is empty, then it is going to be empty as well. Other one is variable count or size, so from type of integer, and this one return my nodes dot count, so size of my array, gonna return that. Okay, so let's see what else I need to do. I need to say, okay, add inline underline double underline always. I just say internal function, so this function name gonna be parents index and of index I from type of int. So for body of this, actually yeah, I need to say that this one return integer. For body of this, I just return I minus 1 divide by 2. Yeah. So just if I want to write explanation, actually some markdown for this, I just say return the index of parents of the element at index I. So return the index of the parent of the element at index I. The element at index 0 is root of the tree and has no parents. So just baseline is gonna be the element at index 0 is the root and no parents. That's why we say I minus 1 divided by 2. Okay, and later I'm going to talk about that's at inline and always. For now, let's zoom on our function. So other one is again at inline always internal function left child index of index should be together of index again I from type of integer, and this one again return an integer. So this one return 2 multiple 1 plus 1. So this is a tree, binary tree. That's why I use, divide by 2, multiple 2, and to calculate parent and left and right. So the other one that I'm gonna declare is right, and this gonna be plus 2 index. Yeah, this is how I traverse my binary tree. Yes, and the other function gonna be public function peak. That's so this one just return 1 t, which is optional, maybe not. Okay, so inside peak we just need to return nodes dot first. Okay, so about this at inline always internally. Actually, I just need to say that this is some property wrapper that tell compiler, actually send signal to compiler, depend of if we put always here or if we put never. So if you put always here, a signal to the compiler that to always inline the method, approach this method inline. And if you put never, it means that signal to compiler that to never inline this method. So what is mean inline means that even though the compiler can make its own inline decision, and the inline attribute can be used to force its decision. Okay, so yeah, that's about it. You can Google it and learn more, but this is what I want to say. So we want to make this our compiler make decision inline when calculating this index or right, left, or parent. Okay, so let's go and continue our codes. We now gonna write our inserts. So first, let me just write some description for insert. So this insert is add a new value to the heap. So this guy, I'm gonna add a new value to the heap. Okay, so what I'm gonna do, it's gonna be public as well to be available for everyone, and it's gonna be mutating, so it's gonna change in inside. So mutating a function. The reason we use mutating because if you remember our heap is a struct, so that's why we have to use mutating. If it is class, then we don't need to use mutate. So we it's gonna say insert, what insert, underline to be broadcast, and so value of type of t. Yeah, and so we not return anything, we just update. What we update, we say okay, our nodes dot append our value. So we append this value to our nodes value. Also we gonna shift up. Actually, the shift up means so nodes dot count -1. Okay, so this gonna be our insert. The other one, again we're gonna do another insert, and this one adds a sequence. So I'm gonna make another insert that adds a sequence of values to the heap. Okay, so to actually just let me just write the complexity here as well. So with complexity, so what is the complexity for the single one? Is going to be O log n, and also it's going to be O log n for this sequence one as well. So what I'm gonna now again I'm gonna write a public method mutating, because it's not gonna return anything, just gonna update my array. So mutating function that inserts. So what gonna insert? So gonna insert it's generic, so I use s, and I name from type of sequence. Okay, and so my function underline sequence from type of s, actually capital S, yeah. And so here I just say var s dot capital I iterator dot elements equal t. So here I just say for value in sequence, what I want you to do, I want you to insert just top one value, yeah. And so let me make this a little bit wider. If let me, should be, oops. Oh, not letting me run right now. Okay, so now just later I'm gonna define sequence as well. I'm gonna do it later. So for now, let me go over. Okay, so now I'm gonna write function for remove. So this function gonna removes the root node from the heap. Complexity gonna be same, O n log n. And so what I say, or I just say at this cardable result. So what is this property wrapper for? This property wrapper actually say in case you didn't get value of this, don't give warning. So sometimes you see that you use some function that's supposed to return something and you're not gonna get it, then you get warning. So to avoid that warning, you can put this here, that if in case nobody take it, don't worry, do not bother me with warning. So return could be return optional. Okay, so the two implement this, first of all, I'm gonna guard my nodes that is empty, otherwise return nil. So what this doing? So we mentioned that if our nodes is not empty, continue. Otherwise, return nil, because our nodes actually are heap is empty. Then we will go and count our nodes. So if nodes dot count equal 1, if it is already equal 1, I just need to return nodes dot remove last. Otherwise, I'm gonna use the last node to replace the first one. Then fix the heap by shifting or sifting. Okay, so I just say let's value equal node 0. Then node 0 equal nodes dot remove last. Then I call function shift down. At the end, I'm gonna return value. So shift, I'm gonna put my last element where it's supposed to be. This is how easy we can remove. And O log n is our complexity. But another remove that we can implement is gonna be, let me use same discardable. As I mentioned, discardable results. It's in case I don't want to use return value for this remove, I won't get warning. I make it mutating because it's a struct, and I'm gonna change my nodes inside this function. So at index from type of int, return optional value of t, which is my heap type as a generic one. Again, I use guard. This time index equal smaller than nodes dot count, then return nil. Otherwise, I'm gonna say okay, let size equal nodes dot count -1. Then I use if index not equal size nodes dot swap a and also index and size. So what I do, just say okay, if index is not equal size, not my say bigger than my size, then I'm gonna swap my index and size actually with the end one. Then I'm gonna shift down from index until size. So from index until size, we're gonna shift down and we're gonna shift up index. Okay, so this if will take care of our remove at index. And then I said nodes dot remove last gonna be what I return. So I put my node at the end. I'm gonna return it, and I'm gonna remove it and return it. So by this way, let's just review. So what we did, we just say okay, from our nodes, swap my index. I want to remove it with size. Actually, put it at the end. Then I'm gonna shift down from index until size. Until size of my heap. I'm gonna shift down, and then I'll going to shift up at this index. And at the end, the item that I put in the last, I'm gonna remove it. It's gonna be remove at index. Okay. So this is for remove at index. Other function I need to write, I used it in top. It's gonna be internal mutating function shift up. If you want to name this shift up, you can go ahead, but you need to make sure to fix it in other function that you call it. So index gonna be from a type of integer. So what this do? It's very important actually for our heap. This is the function that will make our heap. So I just say okay, variable child index equal index. Okay, then let child equal nodes at index child index. Yeah, so my child gonna be this one. Then I'm gonna say, okay, variable parents index equal self dot parents index of index child index. Okay, and so now this is the part that's gonna continue until our index goes to the correct location. So as long as child index bigger than 0 and order 3 area from child and nodes at index parent index, as long as this condition is true, our nodes at the index child index equal nodes at index parent index. Also child index equal parent index and parent index equal self dot parent index of index child index. Okay, so this is end of my function. Yes, so now at the end I just say my nodes child index equal child. So just let's review what we did. So this function takes a child node and looks at its parent. If a parent is not larger or not smaller, so not larger for max heap or not smaller for medium, as long as it's not keep exchanged. So we exchange parent and child as long as it's not larger for max and smaller. So this is what we do here. We continue replacing our child and parent as long as it's not smaller, bigger. And what doing this parent index function. Okay, so this is our shift up. Other one gonna be our shift down. So internal rotating shift down. Actually, shift down gonna be from index, from type of integer, until end index, until end index from type of int. So this is gonna be shift down. So what we do now, we just gonna say, okay, let left child index equal self dot left child index of index from index. So left child index, check it out, and then let right child index equal left child index plus 1. So then I just say variable first equal index, also if left child index smaller than end index and order criteria nodes left child index and nodes first. We use this order criteria to find out if we are max heap or min heap, and then we if this function can approach. Okay, so here inside this we just say first equal left child index. Okay, and we do the same for right. So sorry, yeah, if right child index smaller than end index and order criteria and nodes and right child index and first was true, then first gonna be right child index. So this is how a way we gonna do, and Okay, what else I need to do? I just need to say, okay, if first equal index, then I want you to return because we're done. And also nodes dot swap at index and first. And also I'm gonna shift down. So I called same function, shift down from first until and index. Okay, so this is recursive, so we call it stuff. So let's come here and add some description as well to clear what we're doing. So we looks at a parent node and makes sure it's still larger for what? For max heap or smaller for min heap. Then compare of its children. And we do this here, okay? Actually from here. Okay, yeah, so this is our shift down function. Okay, so we almost done. We just need to do one extension for search. So extension my heap structure where t is equitable. So where t is equitable, then extend it for me. Okay, so let me here also I write mark searching. Okay, so I'm gonna write the function public function index of node t. Okay, so this one gonna return one integer, which is our index, but this integer are optional because it's not guaranteed that we will return something. Okay, so this one return nodes dot index where my operation 0, my operation first actual operation equal no. So this is gonna be function of index, and this is a file. Actually, this is a function that gets the index of a node in the time complexity O n. But also I'm gonna write another discardable result public mutating function by the name of remove that gonna remove node t. So this one removed by value, and you're gonna return t. So how are we gonna do this? You say if let index equal index of node. If you can find this index for me, then gonna return remove at index. Otherwise, return nil. So this function also removes the first, not all, the first occurrence of a node from the heap with the value that we want. And so time complexity gonna be O notation n as well. So first of all we say okay, make sure it is equitable, then go and search for node with this value. If this node exists at when I use var to find it, and that's why I say O notation n. This is a notation that's var need. If it exists, return. If not, gonna be nil, yes, because this gonna return nil. And here you are. Then this index gonna do that for us. So now we can remove the node with value and also. Okay, so now then I finished this. Let me run it. Oh yeah, there is some error. One of them is here says shift down. Oh yes, for shift down here we wrote on this function. I need to write another function, another signature for shift down, which is an internal mutating function shift down. This one get only index from type of integer and not return anything, just shift down, called shift down again, and in a way that say from index until nodes dot cut. Okay, so this one gonna get put nodes dot count for me. Also here, oh yeah, swap. One of them I think I use swap somewhere. It is swap at. So line 104. Okay, let's run. Okay, so left excuse me, line 136. Okay, so let me see. let I think this left child I have mistyping. Yes, so left. I think all should be fine. Let me clear one. Yeah, only one index. Yeah, here I say if, so it should be equal. So I believe now I'm good. Yeah, here we go. No error. All good. So what I'm gonna do now, I need to test this. So when we have our heap completely, completed, to test this, we can use one variable. I'm gonna do both max and min. So max heap, and I just say this is equal my heap, and from type of integer, as it was generic, and so this is max. So sort gonna be criteria, sort criteria gonna be this. So this is my max. Also I make one min heap, yeah, and then it's about to put a value there. So max heap dot insert 30. Okay, so and here min heap dot insert 31. Okay, so what I'm gonna do, I'm gonna put okay, and okay, so here 31, 12, 1, 45, 6, 20, 50, and 9, for example. Okay, so I put same values here, 12, 1, 45, 6, 20, 30, 20, and 50, and 9. Okay, so now I'm gonna print it. So I just say print my max heap here, yeah, and here I just say print max heap. Min heap. Oops. Okay, so min heap. Let's run it and see what's happening. Yes, it's working. Actually, the both are the same. Yes, for min, I should say smaller sign. So yeah, here we go. So let me clear and run this. So you will see I made a max heap easily by and put variable in a different order, and at the end I have maximum number here. I don't care about the rest, I just care about this, and this is minimum number here. So then easily with just O notation 1 I can jump this and have maximum value in my heap. So of course there are some other function as a test. You can use them and see how they are working. So yes, that's it for today. I hope you like this video. Please make sure to give it thumbs up. Also subscribe in case you are interested for watching more video coming every week. And thanks you for watching. If you have any question, please put it in comment below. Any idea, anything that you think may be helpful for this channel. I wish the best for you. Have a good one. Bye bye.